Yes, Dr. Pitt.
Let's humble ourselves and pray. In the name of the Father, and of the Son, and of the Holy Spirit. Heavenly Father, we'd like to thank you for the gift of today. We thank you for the gift of life. Father, as we start off our discussion and our lesson for today, we call upon your Holy Spirit to come and bless us with the gifts of understanding, so that we're able to get the concepts very well and prepare ourselves for our final examinations. We thank you for the precious time that you've given unto us to share this moment and this lesson together with our teachers and fellow classmates. We ask all this through Jesus Christ, our Lord. Amen.
Amen. Thank you so much. From the message that I received in my inbox, many of you asked that we go through the integration of trigonometric functions. That's what many of you asked. Others were asking for partial fractions and the rest of that, but we can review those topics in your free time, but we shall discuss towards the end of the lesson. And today our major focus is going to be integration of the trigonometric functions. In case you have a question in the course, then kindly you raise up your hand and then you ask. So we are going to look at how we integrate trigonometric functions, and that's going to be our focus. In case you have not dealt with this topic at school, don't worry. We are going to start from the basics and then we build on until we reach the final end. So we have 2 hours to do this, but much as I know we may not complete everything, but I know by the end of the lesson, I expect everyone to pick something. So you can write your heading, integration of trigonometric functions. That's what we are going to look at. And basically, when we talk about integration, integration means summing up things together. That is the English word, and is the way to explain. Whenever you eat food, inside your mouth, you break food. So the process of breaking food is what we call differentiation. But when you combine, when those the different particles come together, that's what we call integration. So integration means summing up things together. So we are going to look at how do we integrate trigonometric functions. But before we dive into integration of integrating trigonometric function, you must have an idea on how we differentiate. If you don't know how to differentiate, it means that you cannot be able to integrate. So let me ask you now, everyone, I know each one of us here has done some kind of differentiation. Let me test whether we remember how to differentiate the different trigonometric functions. So you can just raise up your hand and you tell us, our first function we have here is differentiating sine x. You can raise up your hand and you tell us what we obtain when we differentiate sine x. Another person will tell us what we get when we differentiate cos. So you can raise up the hand and you tell us what we obtain when we when we differentiate. Okay, yes, Samuel. Yes, Samuel, you can unmute. Oh, sorry. Yes, Samuel. Oh, I'm not getting Samuel. Yes, Frank, unmute. Frank, you can unmute. Yes, engineer, unmute.
Good afternoon, everyone. When you differentiate sine x, we get cos x.
Very good. So here we shall get cos x. Good. Yes, I'm seeing another person, Michelle. Michelle, unmute. Just unmute. Samuel, Dennis, any of you can unmute.
Yes, sir.
Yes.
When we differentiate cos x, we get negative sine x.
We get negative sine x. Very good. Another one. What is I saw ya konya olata. You can unmute. Or Letitia. I saw Letitia. Frank.
You get sec squared x.
Okay, when you differentiate tan, you get sec squared x. Very good. Another one can tell us what when we differentiate sec, what do we get? Frank, I'm
You
seeing
get
your hand. Okay. Samsung, you can go on.
you get cot x.
When you differentiate, we are differentiating sec x, you get?
Cot x tan x.
Okay, thank you. Members, do we agree? When we differentiate sec, do we get cot sec?
No.
What do we get?
Cot x.
Shrek is saying we get sec x tan x. Okay.
Yes.
Then when we differentiate cot x, what do we get?
Negative cosec squared x.
Negative cosec squared x. Then lastly, when we differentiate cosec x, what do we get? Yes, engineer.
Cosec x, we get negative cot x, cosec x.
Negative cot x.
Cot x, cosec x.
Very good. Now, dear members, as we dive into the integration of trigonometric functions, you must be familiar with what we obtain when we integrate the different trigonometric functions. So what our friends have told us is what we obtain when we integrate. And that table is very, very paramount as we dive into the integration. So I want you to first summarize it somewhere, because it's going to be very important in order for us to be able to understand the integration of trigonometric functions. So I want you to summarize this table, that when we differentiate this is what you get. And that one, you may not need to cram, because when you check your log tables, it is always given. But let us first summarize. When you summarize, you tell us in the chat that I'll finish to summarize. But being a scientist, you can at least have these common ones in your head. So summarize. When you finish, you let me know in the chat that we can continue. Yakone, I'm seeing your hand still up. Okay. So we are summarizing. We are summarizing. When you finish, just type in the chat that I've finished. And then so you type in the chat that I've finished. Preeti has said she has finished. Joy has said he has finished. So 2 people have finished. Okay, so first 7. Okay, I think many of us now are finishing. Okay, done. Almost. Okay, we'll give you some 2 minutes to complete, and then we'll continue. So, okay. This is going to form our basis for this lesson. Once you know how to differentiate, the integration is going to be easy, done. Okay, members, can we continue? Can unmute and you tell us, should we continue?
Yes.
Okay.
Yes, sir.
Okay. Now, this is where now the mathematics is going to come from. Now, what happens is that integration and differentiation are related. Those two things are related. Integration, the reverse of differentiation is what we call integration. Now, we are going to look at two things. I'm going to look at cos x. What does it mean? It means that when I have the integral of cos x dx, when I integrate cos x, what I get is sine x, meaning that when I integrate cos x, I'll obtain sine x plus what we call a constant of integration. So whatever thing you have this side that we have differentiated, take an example. When I have negative sine of x and I integrate it, what will happen is that when I integrate sine x, this negative that is on sine is going to cross over and it comes this side of cos. So it means that when I integrate sine x, I'm going to end up with negative cos of x plus c. So always we want to integrate a positive function. What does it mean? In case I integrate sec squared x now, I'll have sec squared x dx. When I integrate it, I'll get the other side. So I'll end up with tan of x plus c. Members, are we together on that? Is that step fine?
Yes, teacher.
Who can tell us what will happen when we integrate now sec x tan x dx? When we integrate this, which answer do we get, class?
Sec x.
Sec x, very good. So we shall end up with sec x plus a constant. Members, are we together on that?
Yes, sir.
Okay. What about when we integrate cosec squared x dx? Which answer shall we get?
Negative cot x.
We shall get negative cot
X.
plus a
Plus.
constant. Are we understanding, members?
Yes, sir.
Okay.
Yes, teacher.
Okay. For the last one, what answer shall we get when we integrate cosec x cot x?
Negative cosec x plus c.
Plus C.
Very good. We shall get negative
Negative
cosec
cosec
x plus
C.
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 Is that fine, members?
Yes, sir.
Okay. Can go on and summarize. When you finish to summarize, you let me know. Okay, I can give you the summary, no problem. And these are the ones that you need now to know as we dive into the integration of trigonometric function. So I can give you the summary here and the table. And once you know this, it means you know the whole topic. The whole topic is going to be easy, as long as you know that.
This starting is wrong.
Okay, we are waiting for people to summarize. Okay, Joy has finished. Infinix has also finished. Okay, we'll give some few minutes. Has everyone finished? We finished? Should we continue?
Yes.
Members, we continue?
Yes, sir. Yes, we can continue.
Okay, good. Okay, can continue now. Okay, now this table is what is very important, and whenever you integrate, always do not forget to put the arbitrary constant. Now we are going to start integrating. Now we have different ways we can integrate our numbers, but what is important is that we know very well, like we have seen, that whenever I have an integral, let me say I'm integrating sine of x dx. We have said that when we integrate sine, what answer do we get?
Cos x.
We get our answers cos of what?
X.
X. But is it positive, negative?
Negative.
Negative. Plus a constant. Now, please always note that when we integrate sine, we get negative cos. When we differentiate sine, we get positive cos. So when we integrate sine, we get a negative of a cos. So what is going to happen? Now, always here, when you find that the angle is not a single angle, it's like there is a digit on the angle, what do? We can first say, let the whole of this angle we have, which is 5x, equals to any letter of your choice. Let me say it can equal to u. Now, after letting it, you are going to first differentiate such that you replace what you have as your dx. So when I differentiate this, when we differentiate 5x, what do we get, members?
5.
5.
Five.
So we shall get 5 dx is equal to, when we differentiate u, we get du.
dx.
Very good. So our interest is finding out what is the equivalence of the x. So when I reach here, I will divide by 5. I divide by 5. So I will end up with the x is equal to 1 out of 5 du. Is that step fine, members? Hope we are on the same page.
Yeah.
Are we on the same page?
Yes.
Yeah.
Now afterwards, I'm going to come. I called my angle 5x, we said is equal to u. Where there is the x, I'm going to write the u. So I'm going to come and say integral of sine. Now where there is 5x, we put u, sine u. Now where there is the x, we have said the x is 1 out of 5 du. So I'm going to say times 1 out of 5 my du. Now, 1 out of u being any number, I can write it outside the integral as 1 out of 5 integral of sine u du. This still fine?
Yes.
So we are going to go back. We say that when we differentiate sine of x dx, we get negative cos x. Meaning that when we differentiate, we integrate sine u of du, what answer shall we get?
Negative.
So we shall say times negative of cos of u plus a constant. So 1 out of 5 times negative cos is the same as negative 1 out of 5 cos of u plus a constant. But we know that very well that u is the same as 5x. So our answer would be -1 out of 5 cos of 5x plus first. So that is our integral when we integrate sine 5x dx. Have we understood, members?
Yes, sir.
Yes, sir.
Yes, teacher.
Yes, okay. We can write. We can write.
No, sir.
Where you can ask, where haven't you understood? Feel free to ask. Okay. Okay. Are we good to continue? Okay, people are done. Okay, has everyone finished and we continue? In case you have a question, you ask. Such that we are going to build on. So when we leave you one step, you may not be able to catch up. Okay, I think now everyone has finished. Oh, no, now whenever we are integrating, never leave out the constant c, unless the integrand you are dealing with is a definite integral. We only leave out that c when you have limits. But whenever you don't have limits, you need to bring out that coefficient, that c, onto your answer. So Dr. Henrik, never leave out that c unless you have a constant on it. Okay. Thank you, Engineer Trisim. Okay. Unless there are limits, but in case there are not limits, then you have to continue. We can go to another one. Don't you think you are going to try out for me this one? Let us first try. Let everyone first try. Follow the same procedure. But I want you to first let your angle equal to something, and then we integrate. But you need to know what. So let everyone first try. I'm giving you 3 minutes to try out. Follow the same procedure. Okay, good. Let me hope everyone has tried out. Shane has got the answer. Dan, okay, very good. Ben Carson, Enrique. Okay, this is very good. Good, okay. Now we can test those who have not yet gotten the answer. I think we can do it together as well. Anyone to take us through? Just raise up the hand and you tell us you want to take us through, such that those who are not getting the answer can see the steps you followed. Anyone willing? Okay, yes, or Chen, you can unmute.
I'm not able to write, but I can just take us
Yes.
through.
Okay, I'll write.
So they are giving us the integral of cos 3x dx. So we first say we let the angle 3x to be u. Then after, we are going to differentiate both sides. When we differentiate u, we shall have du the same as 3 dx. Then we want to remain with the dx alone. Shall divide both sides by 3. Then our dx will be 1 out of 3 du. Then we go to our original question. We say in the integral of 3x, we shall now say the integral of sine, where there is 3x, we are going to put u since we let it to be u. Then where there is dx, we are going to put 1 out of 3 du. Then since 1 out of 3 is a constant, we are going to pull it outside the integral. So it's 1 out of 3, the integral of cos u du. Then we are going to integrate cos u since it's now with respect to du. So we can now say 1 out of 3 sine u. 1 out of 3 sine u plus c. So, but we said u is 3x. So our final answer will be now 1 out of 3 sine 3x plus arbitrary constant, which is c. Not necessarily always c. Sometimes you can also use other alphabets. Thank you.
Okay. Okay, thank you. Katie, kind of take note is that when you integrate cos, you get a positive sign. So that negative is not there. Katie, you can kindly check your answer. Whenever you integrate cos, you get a positive. That negative comes when you differentiate. It comes when you differentiate. Okay. Let me hope everyone is now okay. We go to another one. We go to another one. Okay. We are here now. We are here now. Okay, I can first clean my screen and then we can start. Now, what do we have? We have our sec squared x and x. And now our task is, how do we integrate it? How do we integrate it? So you can still first do the same thing. Let your angle. So I will say, let x out of 4 equals to u, my angle. There is no problem with it. Or you can, for this, why do we do like this? Because it becomes very easy when we integrate. We know very that when we integrate sec squared of x dx, which answer do we get? When you integrate sec squared, you get what?
Tan x.
You get tan x d tan x plus c. Meaning that when you have just as an a digit, when you just have just one letter, it is easy for you to integrate. But when the angle is not a single angle, then the best thing you first let. So when you differentiate this, you end up with 1 out of 4 dx is equal to du. So since I'm interested in getting the x, I'll multiply 4 on both sides, and I end up with the x is equal to 4 du. Members, is that step fine?
Yes. Yes.
Okay. Then after we substitute, so I'm going to go back in my integral. I have 3 sec squared. Where there is x out of 4, I'm going to put u. Where there is the x, I'll put 4 du. Because this one I'm multiplying. Now this 4 can multiply with the 3, and I will end up with 12 integral of sec squared u du. Is that step fine?
Yes.
You are multiplying this 3 and 4 because both of them are constants. So don't make a mistake of multiplying u times the angle. Those two cannot be multiplied. And therefore, when we come here, we know that when we integrate sec squared du, we shall end up with tan of u plus a constant. But then you go back and say that my u is the same as x out of 4. So I'll end up with 12 tan of u, which is x out of 4 plus a constant. Members, have we understood that?
Yes.
So we can write, but in case you have a question, kindly ask. When you finish, you let me know such that we can continue. Okay, I think
Done.
has everyone
Yeah.
finished?
Yes.
Okay, okay, okay. So we can continue. Okay. There is another number that we are going to do still together, and then I give you the one for trying out. Now we have another one. So like we have said that always when we are dealing with trigonometric functions, our angles we deal with are angles in radians. What does it mean? That in radians, that's where we use the pi. So meaning that when you are placing your calculator should be in radians. So how do we deal with this? Since they want us to find the exact value, the first thing you need to do, before you substitute in your limits, first integrate your function very well. So I'm going to first integrate the function. I have 3 minus 2 sine 2x, all of it dx. So we know that in integration, I can separate the functions I have. So I can say that this is the same as integrating 3 dx minus integrating of 2 sine of 2x dx. Members, is that step fine? Are we together on
Yes.
that?
So
Yeah.
may
now,
first repeat again. May you please repeat?
okay, I'm saying that when I have, this is one
Yes, sir.
function, 3 minus 2 sine 2x. So when I'm integrating, I can separate them because I know very well that I'm going to integrate 3 on its own. I'm going to integrate this trigonometric function on its own. So when I'm integrating, I can integrate 3 alone and this function alone. So that's what I'm doing. So I'm separating the 3 to integrate it separately, and this minus sine 2x to integrate it separately. Are we together?
Yes. Okay.
Is it
Sir.
fine now?
Yes, sir.
Okay.
Yes, sir.
Now, okay. We integrate. When you integrate 3 dx, what do we get?
We get 3x.
We get 3x. Members, is that fine? Because we know that when you have a constant, here there is an x to power 0, always. X power 0 is the same as 1. So when we are integrating, it means we shall add a 1 on this 0, and then we divide by 1. So this will give us 3, 0 plus 1, which is x out of 1. So that's why we end up with 3x. Minus. Now, let me ask everyone to first integrate 2 sine 2x. Everyone, integrate for me that. integrate that on your own.
It is.
When you finish,
cos.
Some people are getting the answer.
Cos.
It is?
It is cos 2x.
Cos 2x. Okay, thank you. As we wait for the rest also to tell us what they are getting. The rest, integrate, and you tell us what you are getting. Let me check in the chat. Ben Carson is saying cos 2x. And the rest, what are you getting? Don't fear. You can even put it aside. When you are dealing with these numbers, you can put it and say, let me first integrate 2 sine 2x dx. So we say that this means you can pull out this 2 being a constant and you integrate sine 2x dx. But we said when you reach here, you let. So I expect you to let your 2x equals to u. Find your 2 dx is equal to du. And then have your dx is equal to 1 out of 2 du. And then, so let me look in the chat. Okay, very good. Everyone is getting cos 2x. Dr. Henry, kindly check.
Teacher, isn't it negative cos 2x?
Negative.
Then it becomes a positive.
Okay, yes, Malaika. Yes, Malaika. Yes, negative cos 2x. Good. So here, our answer we are getting is negative cos 2x plus a constant. But since negative and negative, it becomes a positive. So I'll have 3x plus cos of 2x. But now we have limits. So we are going to substitute in our limits. Our lower limit is 0, and then the upper limit is pi out of 4. So since they told us that they want the exact value, it means that when we put in our limits, let us get the answer we are supposed to get. So those pi's are going to remain there because we say that the angle is in radians. So we first substitute our upper limit. Our upper limit, we shall have 3 pi out of 4 plus cos of 2 times pi out of 4. That is the upper limit. Then we say minus the lower limit. We substitute 0. We shall have 3 times 0 plus cos of 2 times 0. Now, some of you make a mistake. You can assume that cos of 2 times 0 is 0. And then you say anything multiplied by 0 is 0. Please, you need to be very careful. It may not be true. So here we shall have 3 pi out of 4 plus by 2, 1 by 2, 2. So remain with cos of pi out of 2 minus 3 times 0 is 0. Cos 2 times 0 is 0. So I end up with cos of 0. Members, what is cos of 0?
It's 1.
It is 1. So we shall remain with minus 1. Then I'm going to ask myself, what is cos of pi out of 2? Members, place your calculator. What do you get on your calculator? Cos, now here you set your calculator in radians. You set your calculator in radians and make sure you put pi the way it is. Pi, the way you see that pi on the calculator. When you place your calculator, make sure you
0
is 0. Members, are we getting 0?
Yes, teacher.
Yes. Good. So what is going to be our final answer? 3 pi out of 4 minus 1. Is that fine? Is that okay?
Yeah.
Yes.
Okay. Let me hope members we are together on that. So that is what they called you. Well, that's what they said. They want an exact value. So we expect that your answer remains as 3 pi out of 4 minus 1. Any questions? In case you have a question, feel free to raise up your hand or you can tell us.
Okay, I have a question.
Yes, ask.
Yeah, what if the limits were not given?
In case,
limit and
Oh, in case the limits were not given, you would have stopped at this step. You just stop at this step. You say 3x plus cos 2x plus c.
Now, Sam, I want to inquire.
Yes.
For example, after me substituting, then I just come and I use my calculator to integrate. Can it also give me the same answer?
Oh, I use your calculator. Okay, the calculator will give you the same answer. Yes, but remember, the calculator only use it when you are proving, when you are
Okay.
proving. Dr. Preet, I'm seeing your hand up.
Teacher, I'm requesting to know, like, what if my answer, I leave it as 3 pi minus 4 out of 4? Is it correct?
Yes, it is okay. It is okay. Okay. Members, should we continue?
Yes. Let's continue.
Hope we're on the same page. In case we are leaving you, please don't let us to leave you. Now, we are going to come up with something we are going to call the general thing. We are going to come up with
Teacher,
something
I mean it
general.
is empty.
Oh, sorry, I removed. Sorry. Are you still writing something? I had removed.
Yes, sir, we're still writing.
Oh, sorry. I don't know because I've removed some things.
No, no worries.
Okay. Let us wait for it to first finish.
So, teacher, I have an inquiry.
Yes.
So, it's similar to the question engineer had asked. It's okay if we just leave it as 3 pi minus 4 out of 4.
Yes, it's very okay.
It's like they wouldn't like ask for an additional working for marks.
Oh, no, that's where it ends. Because those two things are the same. So 3 pi minus 4 out of 4 is the same thing as 3 pi out of 4 minus 1. So these
Teacher,
are the
supposing we work them out further.
Further?
Yes.
Do you think you can go any further?
Like with the pi.
With a pi. Oh, now remember the moment now I think what you want to substitute is 22 out of 7. But once you substitute 22 out of 7, it means that it is no longer a radian because the radian is the pi.
Yes, teacher.
So you must leave the pi at the angle. So the moment you put 22 out of 7, that one is not an angle now. So
yes,
this is how far you can go.
Thank you, teacher.
Okay.
Sir.
Yes.
What if me I get like this answer, which is 1.3561944.9, then I say radians? Is it also correct or?
Now, that one you have simplified and you have not gotten the exact value. Because the moment you get 1.3 what, it means that there are other values that are coming after. So there were other values that were coming after. So meaning you are not exact. That's not the exact value. Okay. So for you, I've set your own question.
Okay.
So the moment they tell you that they want exact value, it means that there is some kind of format. You must leave your answer. At times you may find your answer, you are going to leave it in format of, let me say in form of SADS. So it will depend. Yes. But always make sure, don't go.
Okay.
Yes. Okay. We'll continue. Yes, people who want to put pi as 1/8 as the angle in radian, still now that one you have simplified and you are not going to get the exact answer. So the moment you go there, you are not going to have the exact answer. So you just end at that point. And at times, even the examiners may put for you the format they want you to get. At times they will put for you that we want your answer to be in this format. Now I'm going to ask you, everyone, to first differentiate for me these things. Differentiate and put your answer before we do it as a class. Put your answer here. In your book somewhere. So for you, put it somewhere, and then we mark ourselves and see whether we're on track, whether we remember how to differentiate. You let me know when you are finished. Has everyone finished to differentiate? And please, one thing I don't want you to have is the cram work, to cram. That's why we are starting from the basics. You need to understand such that even if they twist the number in which direction, you can. Okay, I've seen Ochen has got an answer, but maybe let me first bail you out. It seems some of you are not yet there. I'm going to do for you one, and then you do the rest. So we have sine ax plus b. Now, when we are differentiating these trigonometric functions, I told you we mix the two. When we are differentiating trigonometric functions, still I want you always to learn how to equate. Now here I can say that let u equals to my angle, which is ax plus b. What am I going to do next? I'm going to differentiate. So I'll have du is equal to, members, when you differentiate ax plus b, what do you get?
Get A.
We get a dx, because when we differentiate b, b has x power 0. So this 0 multiplies and we get a 0. So meaning that our du is equal to a dx. And therefore, so this is one thing. But still, we have said that our y, ax plus b is u. So it means that we have y is equal to sine of u. Members, what do we get when we differentiate sine u?
Cos.
Cos of u du.
Du.
Now, we need to remember our chain rule. Our chain rule tells us that dy dx is the same as dy du times du dx. Members, do you remember that?
Yes, sir.
So what is dy du? You come back here. So you divide by du, divide by du. So dy du is the same as cos of u. So here we have cos of u times du dx. I divide by dx, I divide by x. So du dx is the same as a. So here I'll have a, which I can write it as a cos of u. But then I remember that what is cos of u, or what is u? U we related it to be ax plus b. So I'll have a cos of ax plus b. So this is what we get for the first one. So here I'll have a cos of ax plus b. Members, are we together on that? Yes?
First repeat, please.
Where? From where? From which point?
From, I'm not seeing the screen. From this part of y is equal to sine y, sine u.
Yes. Okay, we are repeating from there. Now, do you know how to differentiate sine?
Yes, sir.
Yes. So here we shall say dy du is equal to, when you differentiate sine, what do you get?
A cos.
Cos X. Cos U.
Cos U. Yes, but since here you had said that your U is the same as AX plus B, it means that now where there is U, that's what you will be putting. But when we come back to chain rule tells us that dy dx is the same as dy du times du dx. In other words, like these du's can cancel. So when you substitute where there is dy du, I'll put cos of u. Du dx, we obtained it from here because at first we had u is equal to ax plus b, meaning that our du dx will be a, then when you differentiate a constant, you get 0. So where there is du dx, I will put a. So that's why we have a here. And then I substitute. Is it fine?
Yes.
Okay. Okay, good. Dennis, you have a question?
Yes, sir. I think to
Yes?
make it simple, during time of exam, some people may be erring because of time. Now, since we know how to take sine aspect, we put all what is inside the bracket as the angle. So what is bringing confusion is what is inside the bracket. So we tell them that what is inside the bracket, we treat them as the angle. We don't mind of the sine.
Okay. Yes. Okay, thank you, Ochan. Yes, so members, what do you do? The simple trick is here, like Ochan was telling us. For you, look at what is inside here. Differentiate it. So when you differentiate it, put it outside is A. Then ask yourself, what happens when you differentiate sine? That when I differentiate sine, I get cos and put the angle the way it is. When it comes to here, differentiate what is the angle is. Our angle is A. So I'll put here my, when I differentiate AX plus B, I get A. Then I ask myself, when I differentiate cos, what do I get? That I get negative of sine AX plus B. Members, are we on the same track?
Yes, I think we are.
Yes.
Yes?
Yes.
Okay. Then we go to the last one. Still, look at the angle. Differentiate the angle. What do you get? A. Then ask yourself, when I differentiate tan, what do we get?
Sec squared.
Sec squared. And then our angle is AX plus B. Members, I don't know whether we are picking.
Yes, we are.
Okay. Are we good to continue?
Yes.
Yeah.
Okay. Yes. Now, this is what you did in differentiation. And this is where I want to base on to show you some general formula. Yeah, that's why I wanted you to first remember that from your differentiation before we dive into now the integral part, how we integrate. Okay. Now we'll continue. Let me even first give you the same thing will happen. Esther has reminded me of something. At times you'll find in numbers, they'll give you something like this. They tell you sine of maybe 5x plus 4. You apply the same. For you come to the angle inside, differentiate it. You get, what do you get?
5.
5. Come. When you differentiate sine, what do you get?
Cos X.
Cos. Then
Yes.
put the angle the way it is. 5x plus 4. Is that fine?
Yes.
So that is what we call your y prime, or what we call dy dx. Okay, so that rule you must be able to know it such that it becomes very easy. Now, this is where we are going to apply. This is where we are going to apply what we have been looking at. Like we said that integration and differentiation is the reverse of each other. So what happens is that, take an example. This is what we have as our difference. So in order for me to differentiate, this is what to integrate, I'm going to say, when I have cos AX plus B, cos of AX plus B, dx. When I integrate it, members, what are we going to get? This A that is accompanying it, we remove it. So I will divide by A, I divide this side by A. So my answer will be 1 out of A sine of AX plus B plus a constant. Members, let me know whether you have understood that trick.
But sir, the A is not there on the course.
Yes? No,
You don't put
like,
the
now,
it's
always you first remove any letter with it.
We pick the concept now.
Hey,
oh, I get it now.
you get it, eh?
Yeah.
Yes.
We go to the next one. Now here, I'm going to first remove this. I take it this side. So what shall we have? When I have sine AX plus B, the X, members, tell me, what shall we have?
Negative 1 out of
Negative 1 out of A.
Then
Cos AX
X
plus.
plus.
X plus B.
Yes, I don't know whether we are moving on the same. There are some people who are very quiet. I'm worried we may be leaving you. Yes, Catholic, tell us, are we together? Faith, are we together? Joseph, Mary, are we together? Letitia?
Yes. Yes.
Okay, Faith, let me now hear any girl or the girls to tell us which answer we shall have. Now, in case I have sec squared, AX plus B, the girls, this is for you. What answer shall we have? Mm-hmm.
1 over A tan AX plus B.
Very good. AX plus B, then plus a
Plus
constant.
C.
Good. Now a quick one. I have this. Let me see whether people now are mastering how we are going to integrate. Now, what is the trick? The trick is that for differentiation, we have said that for you differentiate this, multiply it. For integration, we divide. For you after differentiating, what you have got as your answer, instead you divide it, you do not just multiply it. Are we getting the difference?
Yes.
Take an example. When I have sine 3x plus 4, members, which answer shall we have? I want you to first, the answer you get after differentiating your angle, you just say 1 out of that answer. So which answer shall we have? 1 out of
3.
Then when you integrate sine, what do you get?
Negative cos.
So I'll put negative cos, I put the angle 3x plus 4 plus a constant. Members, is that fine?
Yeah.
Yes, sir.
Yes, eh? Okay, are we on the same page, members?
Yes.
Okay, yes. So can we summarize them? Can we summarize them?
Yes.
Okay, summarize. Let me give you some time to summarize. ITEL. There's a person with ITEL. I wanted to get your feedback. Oh, ITEL, you can't hear us. Yeah. Okay, Brian has finished. When you finish, okay. Members, should you continue?
Yes, sir.
Okay.
Yeah, let's proceed.
Yeah?
Let's proceed.
Okay. We'll proceed. Huh? Okay. We can now Those who have not finished? Okay. So we can continue. Okay, so always do not forget. Now, can everyone try out this number? Try out on your own and see. Let me check. People might have even the answer already. Okay. So try it on your own and then we see. Okay, I'm just checking the chat. Okay, Malaika, yes. Good. Thank you.
Teacher, I wanted to say the answer.
Okay, Malaika, tell us what you have.
Negative a third cos 3x plus 1 plus c.
Negative a third.
Cos into brackets 3x plus 1 plus c.
Oh, have I put another number? It seems. Wait. Seems I've
Yes,
changed.
you have changed the number, teacher.
Yeah, okay. Okay, I have 3x plus
1
plus
c.
Perfect. Thank you, Malaika. It is correct. Members, do we have that answer, everyone?
Yes.
Okay. Okay, we can continue. We are trying that. Yes. Now, what if it is in the paper? So don't forget, here, in fact, here, you can relate the way we have been relating. It is very okay. Don't mind. Okay. Yes, Dennis?
My answer is 3 out of 5 sine open bracket 5x plus 1 close a bracket plus c.
Okay, thank you, Dennis. We wait and see what others are having. Members, do we have the same?
Yes.
Yes, teacher.
Yeah,
The same answer. Okay. Wow, perfect. I think this is very okay. Now this one is going to be your exercise you're going to do in your free time. So I want you take a screenshot, or you want us to test one number?
I'll try.
Yes. So, yes,
Do you want us to test one number?
yes, sir.
Okay. Just choose any number you want us to try, and we try it as a class.
Teacher, 2b.
2B, eh? Okay, 2B. 2B, Let everyone now first try. 2B is here.
Even 2F.
Okay, even 2A. Any of your choice.
Five, please.
Eh?
Number 5.
Which one?
2F, the last one on number 2.
Okay, so we are testing. This is the number we are doing as a class now. Let everyone try. Let us first try. Abra? Okay. Oh, is that good? Yes, Abra?
I'm not seeing clearly.
You are?
I'm not seeing clearly.
Oh, you can't see clearly. Like they are very small? Oh,
Yes, they are very small.
okay. Okay, let me help. So, uh, I'm going to just zoom on that number. So what to do? Are you able to see it now? Abra, are you able to see it?
Yes, sir.
Okay,
Yes, sir.
we are doing part B. Everyone is trying out part B. When you finish, you tap your answer in the chat and we see what we have. Oh, sorry. I'm waiting in the chat to look at your answer. Don't forget, when you are dealing with these ones, your calc must be in radians. Your calc must be in radians. I'm waiting for the final answer. Don't forget it has limits, eh? It has limits. So I want you to fill in those limits. Don't forget, fill in the limits. Fill in the limits. Fill in the limits. Because, okay, someone is getting 0.25, okay. Kinto has 1. Adrian has negative 3.6. Okay.
I have 1.
1.
Okay.
Just checking. Peter 1, Dennis 1, Fleet 1. Okay, I think many of you have finished. We can see where some of us are going wrong. So we have our integral of sine half x dx. I don't know which approach you have used, but those who have used the letting approach, it is okay. Saying a half x is equal to u, and then you said a half dx is equal to du, that is okay. Those who have used so then you say that my dx is equal to 2 du. And then you come and said integral of sine of u dx, which is 2 du, which is the same as 2 sine of u du. And when you integrate sine, you get negative 2 cos of u plus c, but your cos becomes negative 2 cos over half x. Then when we put in limits 0 and 2 out of 3 pi. Now here I think the mistake members are making, you are not putting your calculator in radians. So I'll have negative 2 cos over half times 2 out of 3 pi minus -2 cos of 0. So what is going to happen? This 2 and the 2 is going to cancel. So -2 cos of pi out of 3. Here cos of 0 is 1. Yes, then I remain with negative, which is +2. I don't know that that's what members are getting.
Yes.
Yes, eh?
Yes.
So
That's
when
the
I
one.
place, okay.
Yeah.
So I know cos of pi thirds, this one. Did you get a half?
Yes.
Yeah. So this becomes a half +2. Members, when you place your calculator, cos pi out of 3, the answer you get should be a half when you have your calc in radians. But in case you have used 180, in case you have not changed your calculator and you have, in case you have not changed your calculator to radians, and now for you, you want to use 180, it means you say cos of 180 out of 3, cos of 60, and cos of 60 is 0.5. So here it means you are not working radians. You have substituted your pi as 180. So here you end up with -1 + 2, which is 1. Yes, Malaika?
Thank you, teacher. I have an inquiry on this part where we're substituting. So, teacher, this -2 applies to everything. You can't put it outside. Because I put it outside and I calculated. This 2 out of 3 pi. I calculated it, and 0, I calculated it using cos, and cos a half x. I substituted it. I didn't add the -2, but I still got the same answer. Is it
it is
wrong
okay.
or is it correct? No. Should I put that?
Okay, it
When
is
I
okay.
put -2 outside, it's okay.
It is okay if you do it like this, knowing that that negative will come back. So here I expect you to have -2 cos of 0. Such that here you end up with the, here I think it will be, this one will be 2 cos, I think here it will be a half. Here it will be 1 minus 2. So in Malaika, did you remain with 1 minus 2?
No, teacher. I put that -2 outside, the -2 itself outside.
Oh, yes,
Yes.
it is correct. -2, and then you only dealt with cos, a half x.
Yes, teacher.
It is
It's
okay.
correct.
Yes.
Yes. Okay. Thank you, teacher.
Okay.
I think I even used
Members,
the same
someone forgot -3. Oh, the mistake was canceling 2. Okay, fine. Okay. So I think we are good to continue. Take a screenshot, but I'm going to share the work, no worries. I'm going to share a new group such that you can try out other numbers. Now, Malaika, your hand is still up.
Oh, sorry, teacher. My bad.
Okay. Now let us first write integration of odd and even powers. So first write that, summarize, and then we are going to look at them. Seems members have finished. Now I'm going to give you a task. Yes, I'm going to give you a task, members, to try out for me. We have two identities, and let me hope everyone knows how those two identities come into. So those who remember when you were dealing with the with trigonometry, you reached somewhere where you used the double angle identities somewhere. So that's where we are building up from to come up with those identities. So I'm going to ask you to make for me sine squared x the formula, the subject of the formula. That is my task. I want you to, I'm just testing whether we remember. I want you to come here, use this identity of cos 2x equaling to 1 minus 2 sine squared x, and make for me sine squared x the subject of the formula. After that, make for me cos squared x also the subject of the formula. When you finish, you let me know, and then we start from there. That is the task. Everyone, try it on your own. Then we are going to mark our source. Those identities are going to be key. Yes, Abra. Yes,
when
Abra.
I'm making sine squared x is the same as 1 out of 2 into 1 minus cos 2x.
Okay. Thank you, Abra. We are going to look at another answer also, and we compare. Yes, Malaika.
Teacher, is this the one for when sine squared x is the subject?
Yes.
I got a half into brackets 1 minus cos 2x.
Okay. Okay, thank you. Well, let me hope, members, this is what we are getting. Looking in the chat, I saw an answer like that. Thank you. Yes, those who are not getting here, kindly, like they have told us, in order for us to get there, someone can take us through just briefly to tell us what you have done. Oh, yes, Abra.
We take because we have cos to x equals 1 minus 2 sine squared x. So we take minus 2 sine squared x to the left, and then we divide both sides by 2.
Okay. So since this one is negative, we shall take it this side. It becomes plus 2 sine squared x. Since I want to make the subject, I bring cos 2x this side. So it gets 2 sine squared x is equal to 1 minus cos 2x. I divide by 2. So I get sine squared x is equal to a half into 1 minus cos 2x. If this is the answer you have, or like this one, Malaika has given us those answers. Oh, Abraham, they are correct. Correct. Then for this one, cos squared x is equal to, what are we getting, class?
Cos squared x
Ah,
is equal
yes,
to two brackets cos 2x plus 1.
cos 2x plus 1. Good. Let me help members, those are the answers. Now, these two identities are going to be very, very important whenever we are dealing with integration of trigonometric functions. In integration of trigonometric functions, whenever you find the power on cos, on sine, on tan, when they're greater or above a 1, then it means that you need to think of the method that can work for you, either to use this double formula or to use another approach, but it's not something direct that we need. So that's where we are going to build from. So I'm going to start from here and we try this number. Now, before even I remove the identities, I'm not going to remove them. I'm going to start from here. Now, like we have said that sine squared x is the same as a half into 1 minus cos 2x from the identities we have been having. What does it mean? It means that when I come to solve or to integrate this, where there is sine squared x, I'll replace with the whole of this. So now instead of writing that, I'll say this is the same as a half into 1 minus cos 2x dx. Then this one being a half, there is no problem putting it outside and you remain with 1 minus cos 2x, everything into dx. Then we say that this one being one function, feel free always to let me say, to separate and integrate as one component. Let me say you say integral of 1 dx minus integral of cos of 2x dx. But don't forget a half multiplies everything you have integrated. Members, let me know whether we're on the same page.
Yes.
Yes, eh? So I'll have a half into, when you integrate 1 dx, what do we get?
X.
X. Minus. Let me see whether now you are quick at integrating. When we integrate cos 2x, what shall we have? We said you differentiate what your angle is. So when we differentiate, we get
1 out of 2.
1 over 2.
1 out of 2. When we integrate cos, you get what?
Sine 2x.
Sine 2x, eh?
Yeah.
Then plus c. Is that fine, members?
Yeah.
Yes.
Yes.
So can we now open the brackets? When we open, we get x minus 2, 1 out of 4, sine of 2x plus c. Members, let me know whether you have understood that.
Yes.
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 Okay.
Yeah, done.
Okay. So let's write and then we look at another number. Members, have we finished?
Yes, we're done.
Yes, done.
So we are done.
Yeah. Okay. We have another one here. Now, when we are dealing with such a number, we need to remember quite a number of identities. We are going to use not only one, but two of them. One is that we are going to first ask ourselves, how best can we do this number? Oh, wait. Okay. How best can we do this number? But can you allow me to, have you finished, right?
Yes.
Okay. So do we know that sine of 4x can be written as the same thing as sine squared x, everything squared?
Yes.
We know that?
Yes.
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 Yes. But do we remember that sine squared x is the same as a half into 1 minus cos of 2x? Is that fine?
Yes.
Yes.
Now, when I come back here, I'm going to substitute. So when I substitute, I'll say that now sine of 4x means 1 out of 2, 1 minus cos of 2x, everything squared. Members, is that fine?
Yeah.
Yes?
Yes, sir.
I'm substituting for sine squared x. So this will give us a half into 1 minus cos of 2x times 1 out of 2 into 1 minus cos of 2x. Members, we multiply. 1 times 1 is 1. 2 times 2 is 4. So I say 1 out of 4 into 1 minus cos of 2x, 1 minus cos of 2x. Can I first leave you to multiply for me these brackets and you tell me the final answer after multiplying? That's what I want you to give me. Multiply them and you tell me the final answer.
So it will be
1 minus
Continue.
1 minus 2 cos 2x plus 4 squared 2x.
I beg your pardon?
1 minus 2 cos 2x plus 4 squared.
Members, do we have that?
Yes.
Yes?
Sir. Yes.
Yes, eh? Okay. Now, we are going to bring in another identity. We are still simplifying. But we have cos squared 2x. So you come back in among your identities. You ask yourself. Now, these ones, it is application. We know that sine squared x. Okay, let me use cos. I think I can use cos. I know that sine squared x. Okay, let me use cos. Cos squared x is the same as a half into 1 plus cos 2x. Members, now we ask ourselves, what if the angle is doubled? What if this is 2x? What will our identity be?
A
half
into bracket 1 plus cos 4x.
4x. Yes, thank you. So whenever the angle doubles, also double it. So that is the meaning. So that identity, you can go back and trace when you are deriving, that's where it is coming. So now I'm going to come where there is cos squared 2x. I put the whole of this. So now here I have a quarter into 1 minus 2 cos 2x plus 1 out of 2 into 1 plus cos 4x. Members, are we still together?
Yes.
Yes, eh?
Yeah.
Now, I'm going to first look in the brackets and I simplify. So I'll have a quarter into 1 minus 2 cos of 2x. I open plus a half plus a half cos of 4x. Members, is that fine?
Yes.
Okay. So this will be 1 plus a half. What do we get?
3 over 2.
3 out of 2 minus 2 cos of 2x plus a half cos of 4x. Now I can bring the quarter inside. When I bring the quarter, I'll have 3 out of 8 minus a half cos of 2x plus 1 out of 8 cos of 4x. Members, first let me know whether you're on the same page. Are we on the same page? Members, I'm waiting for your feedback. Are we on the same page?
Yes.
Yes?
Yeah.
Yes, teacher.
Oh.
Yeah.
Now, the whole of this simplified thing we have got is what we are going to integrate. Can you first write up that point and we integrate? Okay, first write. First write, I clear the board and then we integrate.
Done.
Is it okay to clear the board? Can I clear the board?
Yes.
Okay. Yes, Adrian. Adrian?
Hold on, I hate to take us back a little bit, but I have a question here. You see this point here, we started a quarter into 1 minus 2 cos 2x plus a half cos 4x. I would like us to reround on how we got, how we ended up with that deduction, please.
I beg, where exactly?
Where there
This
is
one?
no, the very next step.
This one?
No, the next one as you go down.
Here?
Yes, there. And now we got that half again.
A half, this one, eh?
Yes, yes.
That
No,
half
all
is
of
here.
And the other?
The other? This half multiplies here, and then it multiplies here. It multiplies both of them.
Oh, okay. Seems I'm not. Let me fit this to my screen.
Have you seen?
All right, I can see it now. I was not seeing clearly on this screen. All right, okay.
Okay. Yeah. So now we are going to integrate now. So we said you can separate, so I can decide to say 3 out of 8 dx minus integral. You can say 1 out of 2 cos of 2x dx plus 1 out of 8 integral of cos of 4x dx. Hope we are there. Are we on the same page?
Yes.
Okay. Now we can integrate. So when you integrate the first term, what do we get?
3x over 8.
3 out of 8x. When we integrate the second one, what do we get?
1 over 4 sine 2x.
Sine of 2x. Good. Then the last one?
1 over 32 sine 4x.
Sine 4x. Then plus a constant. Anyone that is stuck? Anyone that is stuck from there? Esther, are we together? Okay. Okay. Can we continue? I want to know, Esther, are we together? Dennis, Samsung, Brian, Faith, Mary, Letitia. Are we good to continue?
Yes, sir.
Okay. Yes, Malaika.
Thank you, teacher. Supposing we don't add the plus C, is it like okay?
No, it's not. Yes. Because
it's not okay. Why?
Because are you looking at this? Okay, let me give you an example. We have said that when we differentiate something, we get the same thing. I want you to tell me, when we differentiate x squared, what answer do we get? Okay, let me say x squared plus 4. When you differentiate this, which answer do we get?
2x. 2x.
2x, eh? Yes, but we know very well that when this answer we have, when we integrate it, we must go back here, not so?
Yes, teacher.
Yes, so integrate for me to x dx. What do you get?
Oh, x squared plus c.
X squared plus c. Now, why we add the c is because we are not sure what number was it.
Oh.
So,
okay, thank you, teacher.
So that's why we keep adding it. But in case you are sure, you cannot ignore. But so here we are not sure what thing is it. So even when you integrate this, when you do this one and you differentiate it, you may not, you are going to go back to that answer, but it might not be exact. There is something that you may need to add on. Okay. We have another one. Oh, okay. We are going to do, I want to do one of this nature. Okay, first write this one. Now, what if you meet that the power is an odd power? What do you do? What if the power you are dealing with is an odd power? What do you do, or how do you go about such a number? Now, what do you need to know? One is that when you find that your power is an odd, we are going to first write it in two forms. One, I can write it as an integral of cos x cos squared x dx. Members, do we agree that it's the same thing?
Yes, sir.
Okay. But we know very well that cos squared x is the same as 1 minus sine squared x dx. Do we agree?
Yes.
Now,
Yes,
this is
teacher.
where now you need to take note of. Now, what are you going to do? You're going to look at the function you have. You look at which trigonometric function has the highest power. When you look at cos and sine, which one has the highest power? Sine, not so? So that is what you let. So you say let sine x equals to u. So then you differentiate. So when you differentiate sine, you get cos of x dx equaling to du, meaning that your dx is the same as du out of cos of x. So I'll come back here. I'll have cos of x into 1 minus, where there is sine squared x, we have said that sine squared x means sine of x, everything squared. So since sine of x is u, it means we shall just put u squared. So here I'll have u squared times my dx, which is the u out of cos of x. When you look very clearly, you can see that this cos and this cos can cancel. So you remain with integral of 1 minus u squared du. Then you can go on and integrate. So here you will have u minus u power 3 out of 3 plus a constant. Then you ask, what was my u? My u was sine. So you have sine x minus sine cubed x out of 3 plus a constant. Members, let me know whether that is clear.
I'm getting it.
Yes. Yes, Isaac.
So I'm asking, you always consider the trigonometric function of the highest power, right?
Yes, yes. That's the one that can eliminate very fast. So your task is to eliminate one.
Okay, okay. Thank you.
Okay. Another question? Has everyone finished?
Yes.
Okay.
No, teacher. No, teacher.
Okay.
Excuse me, teacher.
Yes.
So, teacher, in this part of cos x dx du is equal to du. So you're meaning to tell me that's like the differential before difference? Okay, I don't understand that part.
Oh, like the way, do you remember? Let me take you from here. Like when you have y is equal to sine x, how do you write it? Or you are used to writing dy dx is equal to cos this,
Yeah.
Is this clear? The person who was asking.
Yes, teacher.
Now, instead of y, use u. So u is equal to sine of x. So what it means, du dx will equal to cos of x. Is that fine?
Oh, yes, teacher.
Yes, but since you want the x, you make it the subject. So here,
okay,
to make the subject, you can use two approaches because you have du dx is equal to cos x. So for you can say, let me multiply the x this side, I multiply the x this side. So it cancels. So you get du is equal to cos x dx. But since I want the x, I divide by cos x, I divide by cos x. So it cancels. So that's how we come there.
oh, okay. Thank you, teacher.
Okay. Can we proceed? Yes, someone is asking us, what if we use, also that one can work. Hey, that one can work. Yes, but since here I think we had cos, but you can use also that that identity. Yes, you can use those identities, they can work if you know how to use them. Okay. But I think this identity you have used as same way, sin cubed x is equal to a quarter. Then it is not right. It's not right. You need to revisit it. Something is wrong with it. Okay. I want you to, we are almost finishing, but just give me a minute. I want to share, give a certain link to one of the groups. Just a minute. I see whether I have this link with me. Just give me a minute such that I can share the link to the senior files. Okay. So that is the trigonometry of trigonometric functions. Yes, but like I've told you, it requires a lot of practice. It requires a lot of practice. We may not complete today. We may not complete today everything, but one thing you need to know, we shall continue building on it. But also, I think we are going even to, let me just display my screen a minute, and then you take a screenshot of some few numbers, but we shall try them out. But the ones that I'm interested in, I want you to just give a try to some of these numbers. Take a screenshot. Finished?
Yes.
Okay. Now, even take these ones, take for these ones. Finished?
Yes.
Okay. Yeah. The only number I want to show you is this number here. Take an example for this. You find a number of this nature. Still here, I'm going to just give you a hint. Still, you are going to look at which one has the highest power. When you look at the two, which one has the highest power?
Sine.
Sine. So you say, let u equals to sine of x. So you differentiate the u is equal to cos of x dx. So you're going to see that this cos x will disappear, and then you continue integrating. Have you got the hint?
Yes, sir.
Okay, take a screenshot. I'm going to open the group and you send me the answers you're getting for this particular number. There? Okay. Yes, allow me that we end at this point. Let me share the PowerPoint and also you try out. Why I'm hurrying is that I'm going for senior 5 and it is already 4. So allow me that we shall start from here and the next time we shall meet, but you can make some suggestions in the group. You can make some suggestions in the group. In those who can make it early in the morning, let me say, in case we have people who can make it at around 4 or 5, we can as well have some lessons, and then maybe we cover something such that we don't wait for next week, that one can as well work. It depends on the energy you have. In case you can manage that morning, maybe at 5, maybe at 4. In case you can think about it, and then we plan accordingly. So, but let me open the group and then you can send in your different suggestions on how we can. But someone wants the link for the group. Let me share that link before we leave. Okay, let me just share. We shall start from here the next time we meet, but you can suggest in the group whether we can have those morning early lessons, mainly for math or physics, and then we see how we can catch up. Otherwise, let me wish you a good evening and bye everyone.
Have a nice evening.
Okay.